We spend our entire lives standing in the dark. We mistake the shadows on the wall for actual reality. To build a resilient mind, we must start by doubting our own hardware. We apply Cartesian doubt. This means systematically stripping away every assumption and every belief that can be shaken until we hit bedrock, something absolutely true. Take a block of solid wax. It has a specific shape, sound, and texture. Move it near a flame, and it melts. Every sensory property changes, yet it remains wax. Our senses immediately deceived our initial judgment. A rigorous architecture of mind begins exactly here, with the systematic distrust of our own biological hardware. This diagram shows how raw data operates. It is chaotic. Without structure, it is just physical signs and environmental noise. We have to force order onto that noise. By organizing raw data into readable formats, we synthesize information. From those grids, we extract knowledge, actionable, tested patterns that tell us how a specific system works. At the peak, we reach wisdom. This is the long-term, predictive application of that knowledge across multiple environments. Clarity does not happen on its own. Without deliberate synthesis, we are left staring at useless noise. The internal hardware processing that data is inherently flawed from the start. Our brains operate on inherited evolutionary defaults. We rely heavily on System 1 processing. It is fast, automatic, and constantly jumps to conclusions to save energy. System 2 is our analytical engine. It is capable of complex logic, but it is deeply lazy. It demands immense effort to activate. This creates a biological bottleneck. To conserve calories, our neural architecture prioritizes speed over accuracy. This design flaw corrupts our ability to navigate complex modern environments. Fast decisions are inherently dangerous. This maps our cognitive failure using the ladder of inference. At the bottom rung, we select an isolated piece of data. In milliseconds, we bypass critical analysis, jumping straight to an unchecked assumption. That assumption triggers action. The decision executes before logic engages. In 1986, engineers saw data on O-ring erosion. They assumed the damage was an acceptable risk and acted on that assumption, launching the Challenger. Survival requires a deliberate cognitive override. We must engage System 2 to audit our climb and verify our assumptions before we commit to action. Professional survival requires us to actively slow our internal pacing and intercept our biological defaults. This diagram illustrates the most common strategic fallacy, the belief in a straight, linear path from action to consequence. Real-world complexity destroys straight lines. Actions immediately warp into tangled, unpredictable feedback loops. Ignoring these loops creates the cobra effect. In colonial Delhi, the government wanted to reduce the venomous cobra population. They offered a financial bounty for every dead snake. The well-meaning input triggered manipulation. Citizens bred cobras for profit. When the bounty was canceled, breeders released the snakes, causing total systemic collapse. In complex environments, a linear intervention creates its own opposition. We fail when we assume our inputs will yield a singular, predictable result. The systems architect deploys a mechanical safeguard against the linear trap, the pre-mortem. Before launch, you make one absolute assumption. The project has completely failed. This timeline maps a projection 5 years into the future. The collapse is already a reality. From that failure point, you reverse engineer the timeline. You trace the chain of consequences backward, exposing every hidden vulnerability that caused the collapse. Looking backward from an assumed disaster is the only genuinely reliable method to map systemic loops before they execute. In the modern era, artificial intelligence has commoditized answers. They are cheap and abundant. The ultimate, irreplaceable asset is rigorous human inquiry. This diagram illustrates philosopher John Searle's Chinese room experiment. A system receives inputs, follows a set of rules, and produces outputs based entirely on syntax. But processing mathematical symbols is not the same as possessing human understanding. There are no semantics inside the box. Large language models function as digital sophists, mimicking the patterns of knowledge while lacking any internal grasp of the truth they present. True meaning exists only when human critical thinking aggressively intervenes on machine syntax. When interacting with modern data systems, you must adopt the role of Socrates. First, deconstruct the machine's output. Break the conclusion down into discrete, isolated components. Second, aggressively interrogate the foundational assumptions beneath that data. Finally, rebuild the conclusion entirely from verified first principles, rejecting all external assumptions. This is the completed cognitive architecture, bypassing our biological laziness, mapping the systemic loops, and demanding semantic understanding over syntax. The human mind is a system that will always default to lazy, linear assumptions unless forced to do otherwise. To survive modern complexity, we must continuously demand foundational truth. We have to stop looking at the shadows on the wall.